Okay, factoring. We have tons and tons of factoring, and factoring follows us through the entire year. So we need to get factoring down right now. Okay, this is a warning. If this is something, if you take anything away from this unit, it needs to be factoring. Factoring is the one thing that if you don't get, well, not the one thing, but one of the biggest things, if you don't get it right now, you're going to struggle through the rest of class. Okay, so let's start by just simplifying these, by just multiplying them out, okay? So that's 3a squared plus 7a. That's 2m cubed minus 12m squared plus 2m. That's 4x to the fifth y minus 8x cubed y squared. So it was given to you in factored form first, and then we multiplied it out. So really, we're just doing what we've been doing, but we're going to do it backwards. Okay, so now instead of multiplying, we're just going to pull stuff out and get it to the simplest form we can get it in. Okay? Or not the simplest form, the factored form. Sorry, I said that backwards. So say you have 4a squared plus 8a. The factored form of that would be 4a times a plus 2. Okay? Polynomials that can't be factored are called prime. So there's some steps. Let's just go through this. So we have 5x plus 30y. What goes into 5x and 30y? Well, it's 5. Typo, sorry. That should be a 5. We're dividing both of these by 5. Okay, not an x, sorry about that. So when you divide 5 by 5, you end up with x. You divide 30 by 5, you end up with 6y. That 5, you cannot lose it. Sorry, this is a little confusing. So let's just ignore this for a second. So if we have 5x plus 30y, 5 goes into both of those, so we're going to divide it by 5. Well, that 5 comes out in front. 5x divided by 5 is just x. 30y divided by 5 is 6y. Cool? Okay, let's do another one. Oh, you can check it by multiplying it out, and you get the same thing. Let's do this one. So what goes into 9r to the 8th, 18r squared s, and 24rs squared? Well, 3r goes in all of those. So we're going to divide the 3r out. 9r to the 8th divided by 3r is 3r to the 7th. 18r squared s divided by 3r is 6rs. And 24rs squared divided by 3r is negative 8s squared. You can check by multiplying it back out, and you should always get the same thing. If you don't get that same answer, you did something wrong, we need to go back. This checking right here, you need to ACT tip. If you can learn to check your answer, then tests like the ACT and a lot of multiple choice tests, you're able to check answers by plugging numbers in, and you can figure out right answers without actually having to go through all the work. Does that make sense? My class, obviously, you have to actually go through this, but when you're taking an ACT, a time test, then it's good to do these roundabout tricks, right? Let's do another one. So this one we can divide by 3d, and you end up with 3d times 7c minus 1. Whenever you divide something by itself right here, you always end up with 1. You could divide an elephant by an elephant, and you would still end up with those cancel, and you're left with 1. Okay, because really when you're dividing, it's saying how many elephants can you put into a group of 1 elephant, and it's just 1. Okay, so that was kind of confusing. If you got confused, then ignore that. But whenever you divide something by itself, it's always 1. And yep, check it, and you do get 21CD minus 3D. Okay, let's do this one. There's nothing that goes into both of those, so that is prime. Okay, let's multiply these out. And we're just going to do it by, I can't remember what that's called, distribution. So that's going to be x squared minus 4x plus 4x minus 16. Those cancel, and you're left with x squared minus 16. Same thing here. 25m squared minus 5m plus 5m minus 1. Those cancel again, and you're left with 25m squared minus 1. That should have been a 2a, sorry. So that's going to be 4a squared minus 6ab plus 6ab minus 2b squared. Again, those cancel, and you're left with 4a squared minus 9b squared. Okay, the results here are called difference of squares. And notice the only difference in all of these is a sign. A plus and a minus, plus and a minus, plus and a minus. I don't like that I'm using red. Sorry, I'll change it. Okay, plus, minus, plus, minus, plus, minus. So first you make sure they have, it's an actual difference of squares. It has to be a subtraction sign, and you have to be able to square root both terms. And then use the following rules. So it's just going to be a minus b, a plus b. And you could switch those if you wanted to, like all of these are switched. If you want to have the plus first and the minus second, I don't care. It's the same thing. Okay? So let's do some of these. Let's think of examples of perfect squares first. So like x squared, y squared, z squared, elephant squared, triangle squared, water bottle squared, anything that you have 2 of, okay? 1 squared would be 1. So 1's a perfect square. 2 squared is 4, that's a perfect square. 3 squared is 9, perfect square. 4 squared, 16, 5 squared, 25, 6 squared, 36, 7 squared, 49, 8 squared, 64, blah, blah, blah. You can go on forever, okay? So let's look at this one. So you have a squared minus 4. Well, is this a subtraction sign? Yep. So let's square root both sides. So that's going to be a. Square root of a squared is a. Square root of 4 is 2. So that's a minus 2, a plus 2. Boom, you're done. That's all you have to do. Magical, right? Let's do another one. 81 minus x squared. Is there a subtraction sign? Yes. Are they both perfect squares? Yes. Square root both of those. Square root of 81 is 9. Square root of x squared is x. So that's going to be 9 minus x, 9 plus x. Sweet. Let's do another. K squared plus 25. Subtraction sign? No. So this is prime. There is actually a way to factor this. And I'm going to teach you it real quick, actually. So here, we could square root this, and we could square root this, right? You could still square root them, and this would be k, and this would be 5. The difference here is you do it the same way. So we're still going to put these in here. So that's going to be k minus 5 and k plus 5. But we have to add these imaginary numbers in here. Okay, I'm not going to go into why. That's going to be a later unit, but you still can factor this. For this unit, I would accept this. If you put that, super freaking awesome. If you don't, and you just put prime, also super freaking awesome. I don't care either way. Okay? This one, so 9b squared minus 100, square root both, 3b and 10, so that's 3b minus 10 and 3b plus 10. This one, there is a GCF that we can take out first. So see how 2 goes into both of those? Let's take that out. So you get 2n squared minus 36. Now we can square root those. You get n in 6, so that's 2, n minus 6, n plus 6. Make sure you don't lose that 2. Anytime you take a GCF out, you have to keep it on the outside. Do not lose your GCF. Okay? I skipped some examples. Try to do them if you want to. Now let's do these ones. So we're just going to multiply the same way that we did the last one. So that's going to be x squared plus 5x plus x plus 5, which is x squared plus 6x plus 5. This one would be m squared plus 6m minus 4m minus 24, which is m squared plus 2m minus 24. This one, k squared minus 3k minus 7k plus 21. K squared minus 10k plus 21. Okay, to factor a trinomial, so now these aren't perfect squares and we have a number in the middle, right? That's why it's called a trinomial, because we have 3 terms. You must find 2 integers that multiply to be c, so it's a product of c, and add to be b, so the sum is b. Okay, let's do some examples. This one's a guided example. So x squared plus 7x plus 12. So b equals 7 and c equals 12. So we need to find 2 numbers that will multiply to be 12 and add to be 7. Okay, let's see. So let's start with finding the factors of 12. That's what you're always going to do, is find the factors of C. So we have 1 and 12, 2 and 6, 3 and 4. Now this is a good way to find factors because look how we went 1 to 2, 2 to 3, and then 3 to 4. So that's why I don't need to go to 4, because I know 4 times 3 is going to be 12, which we already repeated there. So once you get your next number in this column, you're done. Now we have to find 2 that will add up to be 7. 3 and 4 will. So this is the answer to the first blank, 3 and 4. And then we're going to put these in the binomials. So we have x plus 3, x plus 4. Distribute to check the answer. X squared plus 4x plus 3x plus 12, which is x squared plus 7x plus 12. Super awesome. Cool? Let's do another one. So n squared plus 9n plus 20. Must multiply by 20, add to be 9. So let's write down the factors of 20. 1 and 20, 2 and 10, 3 doesn't go into 20, so that's sad. We're going to put a sad face. And then 4 and 5. And we got to the next number, so we're done. Okay, now we have to see, will any of these add up to be 9? Well, 4 and 5 will. So that's just going to be n plus 4, n plus 5. Cool. Let's do another. Oh, you can check it. Sorry, I forget to check. N squared plus 9n plus 20. It's always a good idea to check. Let's do the next one. So a squared minus 10a plus 24. So it must multiply to be 24, add to be negative 10. This negative might make this weird. It's okay. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. 5 doesn't go into it, but then 6 is right here. So we're done. So we need to see, will any of these add up to be negative 10? Well, 4 and 6 will add up to be 10, but it's not negative. So I have to change both of those to negatives. Let's double check. So they still have to multiply to be 24. So negative 4 times negative 6. A negative times a negative is a positive, so that's going to be positive 24. Negative 4 plus negative 6 is negative 10. Okay, cool. Whoops. So then it's a minus 4, a minus 6. You can check your answer and you get the same thing. So this one, g squared plus g minus 6. So it's going to multiply to be negative 6, add to be 1. So we have 1 and 6, 2 and 3. It's all the factors. So multiply to be 6, add to be 1. Well, I know that 3 minus 2 is 1. So I'm going to use 3 and 2, but I'm going to make one of those negative. Because negative 2 times 3 is negative 6. Negative 2 plus 3 is 1. So that's good. So that's g minus 2, g plus 3. Awesome. Multiplied out. Sweet. All right, I left 3 examples for you to do. We'll finish the back page in class tomorrow. Remember to take the quiz. And remember that you are all amazing human beings blessing the planet Earth. Okay, bye.